A cards, they just look like these. So for the fourth session after this one, today we're going to have our question and answer time with Dr. Jason Lisle. So if you have a question, you want more clarity on something, please fill out one of these cards. And if you need a card, raise your hand as I'll walk back through here in a minute, and I'll definitely hand you one. And would encourage you to make them pertinent to the topic of discussion for today. All right, so keep that in mind. And we do have a few people coming in, but we're going to go ahead and get started so we can stay on time. So with that said, welcome Dr. Jason Lisle.
All right, I get to talk about my specialty field now. That's always fun. Of astronomy. And that's one of those ones that there's sort of two topics that people really get pulled into, and astronomy is one of them. A lot of people find that very interesting. And the other one's dinosaurs. And we don't have the dinosaurs on our list today, but that's okay. I do have the DVD on it. So astronomy is a way we can use the majesty of God's universe to just kind of introduce people to their Creator and pray that they'll repent and be saved. But it's a topic, too, that the secularists have tried to use astronomy to convince people the Bible's not true. And they'll say, well, we know the Big Bang is the way the universe came into existence. It just kind of exploded into existence from nothing. I've never found that a very compelling explanation. But that is what we're taught in the school system, the secular schools. They teach a Big Bang. They teach that the solar system collapsed from a nebula and the planets formed and so on. It's not a creation. It's sort of an evolutionary process, and I beg to differ. So we're going to look at how the secrets of the cosmos confirm the Bible today. And there are 5 secrets of the cosmos we're going to take a look at, and we're going to see that the Bible is right in all of these areas. The Bible's right when it speaks about God's glory being revealed in the heavens. The Bible's right when it speaks on the issues of the basics of astronomy, things you'd learn in any freshman level astronomy class. The Bible does address some of those things, and it's right. We're going to talk about the age of the universe. The Bible's right when it addresses the age of the universe. We're going to talk about the uniqueness of Earth. The Bible indicates that Earth's not just another planet, right? It's very special in God's plan, and we're going to see that the science confirms that. And then finally, we're going to see that the Bible is right when it addresses the issue of distant starlight. And how do we get that light from those galaxies to the Earth within the biblical timescale? Okay? So let's just jump right in, and we'll take a look at this first issue about the glory of God being revealed in creation. The Bible says as much. Psalm 19:1, the heavens declare the glory of God, the skies proclaim the work of his hands. And that's a beautiful psalm, and the universe certainly does declare God's glory. And it does this in a number of ways, but I'm only going to address 2, and they are the size of the universe and the beauty of the universe. And those are very consistent with the universe having been created, spoken into existence by God himself. I think the more you know about the universe, the harder it is to believe it's just something that just kind of happened or exploded into existence or what have you. So this is one of those areas where the more we know, the more we see God's glory revealed. So the size and beauty of the universe. Now, the beauty of the universe, you don't have to be an astrophysicist to appreciate that. You can go outside on a clear night. You got to get away from the city lights, but and look up and see, wow, it's amazing, especially in the summer when you get the Milky Way going overhead. It's beautiful, stunningly beautiful. And what a privilege that we live in an age where we have things like the Hubble Space Telescope, and I'm sure you've seen pictures of it, and it's just amazing. The more you zoom in on the universe, the more beautiful. That's amazing. The size of the universe, that's a little harder to comprehend, and I dare say none of us really comprehend it. We can write numbers to describe distances to things because we can use scientific notation, which allows us to express insanely big quantities within a very succinct notation, but it's not something we can really wrap our minds around. But what I can do is compare things to other things and just give you a feel for the kinds of sizes and distances we're talking about, and it's mind-blowing. So keep in mind the beauty of the universe and the size of the universe as we look at these various things. We're going to start with the moon. The moon is about the same size as the United States. If you were to put the United States at the same distance as the moon, it would cover about the same area in the sky. So this is a mosaic image of the moon. It was taken by taking lots of high-resolution images and stapling them together. And you can see in some places they didn't get the contrast exactly right, so it looks a little bit off, but that's why. So I love looking at the moon. I love looking at it in a small telescope. because it's just so much more detailed than anything else that you can see in a small telescope, and because it's so close. The moon's only 240,000 miles away. That's our next door neighbor. Now, that is one of those distances that you can kind of get a feel for it, because some of you, if you have a really good car, it might have 240,000 miles on it. So some cars could have driven to the moon, but probably not back. Okay? So that gives you kind of an idea. The astronauts that went there in the 60s, it took them a few days to get there, but they were traveling at the speed of a bullet. So that's pretty neat. When you look at the moon in the small telescope, it really is stunning. And especially when it's in the first quarter phase, when it's illuminated right down the middle, right? We see half of it, half of it light, half of it in darkness, because then you can see the shadows of the craters, and it's stunningly beautiful. And your brain is able to immediately figure out that it's spherical, it's a three-dimensional object. And so it's not only a testament to God's glory in space, but in his creating our mind. We have this amazingly sophisticated computers in our head that's made out of meat. That's pretty amazing. And it just immediately figures out it's a sphere. It's pretty neat because of the way the light and shadow work. And then again, when I'm showing people the moon in the telescope, and it's usually wow is the first reaction, and the second is, can you see the flag? Can you see the flag that the astronauts plant on the moon? No, you can't see the flag. This is the size of the United States, okay? It's big. You're not going to see something that small. But the interesting thing is there's a spacecraft that was orbiting the moon, the Lunar Reconnaissance Orbiter, taking very high-resolution images of the surface. And we now have the moon mapped in so much detail, we can see where the astronauts landed. And it's pretty spectacular that we can do this. And so let's zoom in here on Mare Tranquillitatis. This is where the first moon landing was. And as we get a higher and higher resolution, thanks to the Lunar Reconnaissance Orbiter, you can see there in the middle, that's the lower section of the lunar module. Remember when they landed on the moon, when they took off, they launched only the top portion of the spacecraft to save fuel. And so the bottom portion, that spider-like looking structure, that's still there, along with some instruments that they left on the surface. And you can also see that dark streak right there. That's the footprints of the astronauts as they walked over to that crater and back. So that's pretty neat. So you got 50-year-old footprints there. And they're not going anywhere because there's no weather, there's no atmosphere on the moon. There's no maid service, so the footprints are going to be there for a long time. Pretty neat. And there's some instruments that we left on there as well. One of them is a reflector that's designed to reflect exactly in the opposite direction of any incoming light. And people have bounced lasers off the moon off of that reflector. And it's one of the proofs that we've been there. So yes, we really did go to the moon. There it is. You never know these days, right? So the scale of the cosmos really is as amazing as its beauty. So there's the moon, and here it is in comparison to the Earth. Yeah. So we got a pretty big planet, and we do. If you've ever driven through Kansas, we got a big planet, right? Yeah. I've had to do that a few times, and going back and forth to Colorado and so on. The Earth's big, it's beautiful, and what a privilege that we live in a time where we have pictures of our planet from above. That's just neat. Something our ancestors only could have imagined. We have pictures of it. A friend of mine, Jeff Williams, is actually an astronaut. He's just retired, but he's an astronaut. He spent a lot of time on the International Space Station, and he takes pictures of the Earth, and it's amazing. And in fact, we did a conference together one time, and we used this computer to save time. So he put his PowerPoint on it, and I said, Jeff, I'm keeping your PowerPoint, because it was really pretty. And he said, that's fine. So, so the Earth's big, but it's pretty small compared to Saturn. And when you look at Saturn in a small telescope, that's another one where people go, wow. There's something magical about seeing it with your own eyes that the picture just doesn't quite convey. Now, it's small when you look at it in the telescope. It looks like that. You just want to grab it, stick it in your pocket, and take it home with you. But you can't because it's 9 Earths across. And the reason it looks so tiny is it's 1 billion miles away. So that gives you, and at that point, I'm gone, right? 1 billion, I can't comprehend 1 billion miles. That's totally beyond my comprehension. We can put a number to it, but picturing it, not possible. Of course, you have those lovely rings on Saturn, and you can see those in a small telescope. Those are trillions of tiny little moons that orbit around Saturn's equator. It's of rock and ice. So it looks solid, but they're not. Okay, each one's solid, but it's a large conglomeration of them. So you say, well, at least we got some big planets in our solar system, even though the Earth apparently isn't in the top 4. But Saturn's small compared to the sun. And of course, at this point, you can barely see the Earth, right? The sun is 100 Earths across, just to give you a feel for it. And if it looks small, that's because it's 93 million miles away. It's basically a stable hydrogen bomb. It's fusing hydrogen into helium in its core, and that releases energy. It releases more energy in 1 second than 1 billion major cities on Earth could use in an entire year. So, and you say, why would God waste all that power? God has unlimited power. And so it's not a problem for him to make a sun that does that. Stars are suns. Those little pinpricks that you see in the night sky, those are the same type of thing as the sun. And that's amazing, because they put out an enormous amount of energy as well. The sun is classified as a main sequence, a yellow main sequence star. Main sequence means it obeys a rule where if you know the mass of the star, that determines its other major properties, its brightness, its size, its color, and so on, its surface temperature. And the sun obeys that rule. About 90% of stars do, and 10 don't. 10 are bigger. Main sequence stars that are less massive than the sun are called red dwarfs. And you can see they're a bit smaller than the sun. They're very, very abundant. Red dwarfs are very, very common, but they're not very bright, so you don't see as many of them. They can't be seen to as great a distance as a star like the sun, or ones that are hotter than the sun and more massive. Those tend to be blue, like Mintaka. That's a blue supergiant. It's one of the stars of Orion's belt that you see in the winter sky. But there are stars bigger than that, like Canopus. That's pretty spectacular. And you can see Canopus this time of year. Yes, you can see it from Texas. Yeah, we're in the right time of year to see it. It's in the evening sky, very low in the south. That's Canopus. It's huge. It's bigger than the sun and considerably brighter. But there are stars bigger than Canopus, like Antares, for example. It's over 600 suns across, so it's big. And that's, again, one of those stars that you see in the summer sky. It's quite beautiful and red. The inner planets, if we were to put the Antares where the sun is, we'd be inside it. That's that big. It extends out beyond the orbit of Mars. So it's pretty spectacular. Now, some stars are like the sun. They kind of by themselves. Some stars come in binary pairs. And some stars come in these amazing clusters, like this beautiful globular cluster that you see there. And they are amazing. These are some of my favorite things to look at in a small telescope. Yeah, you can see these in a small telescope. They're beautiful. There's probably about 100,000 stars in that cluster. And the Bible says God calls them all by their names. God has a name and a purpose, therefore, for each one of those stars. Isn't that interesting? So these are amazing. There are a few hundred of these that you can see with a small telescope. Some of the prettiest objects are not stars at all, but nebulae. A nebula, that's Latin, it means cloud. And they look kind of like clouds, but they're colorful. Very pretty, very pretty. So this particular nebula, this is the Tarantula Nebula, and it actually has a star cluster down in the bottom right as well. So sometimes you get two for the price of one, which is kind of neat. Star cluster and a nebula. So a nebula, it's hydrogen gas that's spread out over a vast region of space. That's the same stuff stars are made of, but stars are hydrogen gas compacted into a sphere held together by its own gravity, whereas a nebula is spread out in an enormous region of space. So our solar system would not even show up on that image. It's enormous. And if there are stars nearby that nebula, they'll heat it up and cause it to glow, and they're so pretty. And so these beautiful abstract artwork from the Lord, painted on an enormous canvas, really a delight to look at these. I do have to point out, when you look at these in a small telescope, because you're using the rods of your eye, you don't really see much of the color, but they're still pretty. They still have this smoky and beautiful appearance to it. So there you go. Yeah. So some nebulae are relatively small, and they're produced by a single star that's ejecting gas, and so it forms these interesting shapes. These are called planetary nebulae. These are only about the size of the solar system. Okay, and they're dynamic because as the star ejects more gas, they change from century to century. So there you go. And often you have a two-lobed structure where the star is ejecting gas. We think it gets channeled to the north and south poles of the star, so they call that a bipolar planetary nebula because of the two poles. And then other planetary nebulae are round. Some of them are. And it could be the ones that are round are also bipolar, but maybe we're looking right down the barrel. We don't really know because we can't get another angle on it. So, because we're here and we're not going anywhere anytime soon, so there you go. One of my favorites, it was the first that I learned how to find, was the Ring Nebula. and not far away from the star Vega in our summer night sky, very high up. It's a beautiful little nebula. And again, it looks gray. In a small telescope, you can't quite pick out the colors, but nonetheless, it's very pretty, very pretty. And there's a star in the middle that has collapsed in on itself. It's a white dwarf, and so that star is about the size of the Earth, but it's bright enough that we can see it even from that distance. So this is where a star has kind of ejected its outer layers of gas and formed that bubble. Very interesting, very pretty. And it's so strange, too, because this is one of those ones it's easy to spot in a small telescope. It's very easy to find. And most places you point a small telescope, you'll just see stars and stars and stars, and they're very pretty. There's one spot where you will see a glowing smoke ring. It's so strange to see this little cosmic Cheerio suspended on nothing there in space, and you're kind of expecting it to expand, and it is. It's just you don't notice it in a human lifetime. So there you go. That's the Ring Nebula. All these things we've looked at, these stars, moons, clusters of stars, nebulae, are part of a much larger structure called a galaxy. And before the 20th century, we thought our galaxy was the only one. Now, astronomers could see other galaxies. So what you're seeing here is a collection of about 100 billion stars. So many, it's hard to pick out any individual one. They kind of blend together. And before the 20th century, astronomers could see these things, but they thought maybe these were solar systems in the process of formation and small and within our own galaxy. And it wasn't until the 1920s that astronomers were able to finally measure the distance to these things and realize, oh, these are way outside our galaxy. These are other galaxies in their own right. So we live in a structure like this, about 100 billion stars, called the Milky Way. This one's the Whirlpool Galaxy. We think our galaxy looks a lot like that, but we don't have any pictures of our galaxy from the outside because we live in it. So that's it. But we think it looks like that. All kinds of galaxies in the universe, galaxies of tremendous beauty. There are galaxies of tremendous ugliness, too. There you go. There are galaxies with large, mysterious arrows next to them. You'll see that in all the textbooks. It's so strange. There are galaxies that have rings of stars around them. That's interesting. There are galaxies that look like flying saucers. That's a real galaxy. That's the Sombrero Galaxy, and that's just a neat one to see. You can see that in a small telescope if you know where to point it. It's in the lower portion of the Virgo supercluster, so it's really stunning. And it's got that dark dust lane. That's dust around the equator of the galaxy that's blocking the light from the stars behind it. It's not like God forgot to put stars there. It's just there's dust blocking them. So, and you can see that in a small telescope. You see that dark dust lane. There it is. It's pretty spectacular. There are galaxies that are in the process of collision. That's kind of neat. And people think, was that a problem? Well, no, because the distance between the stars is enormous. The stars will all pass right by each other. The chances of any two colliding are remote. So it's harmless and beautiful. Probably created already in the process of collision. They've moved a little bit since creation. We got even deeper into space, we find galaxies come in clusters. Those little fuzzy specks you see there, those are not individual stars. Each one of those is a galaxy with about 100 billion stars. Every one of them. And they come in clusters. Amazing. As we got even deeper and deeper into space, this is the Hubble Ultra Deep Field, about as far out as we can go until the James Webb Telescope takes over, and probably by this summer. So those are not individual stars you're seeing there. Each one of those, you mean those tiny little specks in the background? Those are galaxies. Each one of those at tremendous distances, to the point where the combined light of 100 billion stars looks like this little tiny thing that can only be picked up by the Hubble Space Telescope. Pretty amazing. And if you think about it, all that spoken into existence by God. He said, let there be light. Let there be lights in the expanse of the heavens to give light upon the earth. And it was so. All that spoken into existence. All created in 6 days, according to Scripture. In fact, what you're seeing here was made in one day, day 4. 5 of the 6 creation days, God works the earth, makes it right for life, takes one day out, day 4, and makes everything else. And I love the way the Bible describes the creation of all these hundreds of billions of galaxies with hundreds of billions of stars each. It's summed up in this little phrase, He made the stars also. Isn't that neat? What a lesson in perspective. Almost like an afterthought. You know what go really good with an Earth? How about 100 billion galaxies? Why not? And again, people who don't have any conception of the majesty of God will say, well, why did He make all those billions of things, if it's just for us? Well, first of all, it's ultimately for His glory, right? We get to enjoy it, and I'm grateful for that. But God has unlimited power. So why did He make all those galaxies? I don't know, but if it was to impress me, He succeeded. He succeeded. The universe does declare God's glory. It's beautiful, it's huge, beyond imagination. So what about the basics of astronomy? Things you'd learn in any freshman level astronomy class? The Bible does touch on astronomy. And because the Bible's God's word, when it touches on a subject, it's right. Doesn't matter what the subject is. God knows everything, right? So, now the interesting thing, though, is a lot of these places where the Bible mentions something of the nature of astronomy, the nature of outer space, there was a time in the past where experts of the day would have disagreed with that. And yet today we'd have to say, no, the Bible got it right. Let me give you an example of this. The spherical nature of the earth. The Bible actually teaches around earth. In Isaiah 40:22, the circle of the earth. I think even more compelling is Job 26:10, which says that God inscribes a circle on the face of the waters at the boundary between light and darkness. Now that boundary, what astronomers call the terminator, is where light stops or terminates, where evening and morning occur. And the only way you can have a circle the only way you can have a terminator that's always circular is on a sphere. That's the only shape that'll do it. And so Job 26 is a very strong affirmation of the spherical nature of the earth. The interesting thing is, these texts were written, well, let me back up. If you go to a secular astronomy textbook, they will usually credit Pythagoras with being the first person to come up with the idea that the earth might be round. Aristotle is usually considered the first to prove the world's round from things like the shadow of the earth on the moon during a lunar eclipse, which I've seen, and it's a round shadow because we're on a round planet. And the way that the ships, you can see the mast of the ship before the rest of the ship as they approach, because the oceans are curved as well. But Pythagoras is 500 BC, Aristotle's 300 BC, Isaiah is 700 BC, Job we think is around 2000 BC. So the Bible is talking about the spherical nature of the earth long before any of the secularists figured it out, which I think is very interesting. So there was a time, let's say, 800 BC, where if you were in Greece, they believed the earth was flat at that point, and yet the Bible said it was round. The experts said, no, the Bible's wrong. Well, it's not. By the way, the idea that Christopher Columbus was out to prove the world's round is a myth. People already knew the world was round at the time of Columbus. He just thought it'd be faster to go that way, which it turns out it isn't. But I'm glad he made the trip. Earth suspended in space. In Job 26:7, God hangs the earth on nothing. Beautiful poetic description of the nature of gravity. God, you can think of God hanging the earth like a Christmas tree ornament, but hanging it on nothing. And something that God can do. Might have been hard to believe at the time it was written. Again, the early Greeks, even by 800, 900 BC, taught the earth was a flat disk and floated in water. And frankly, that makes more sense to our natural way of thinking, because we've seen things float in water. We understand buoyancy, right? But you can't hang it on nothing. That can't be true. Well, it is for the earth. We have pictures now. So there you go. So the experts of the day were wrong. The Bible's exactly right. Earth literally hangs on nothing. The expansion of the universe. The Bible describes God stretching out the heavens as a curtain, spreading them out as a tent to dwell in. This is mentioned in a number of different places in Scripture. It must be very significant. And yet it was something that was resisted until relatively modern times. Up until the 1500s, most scientists thought the universe was static and unchanging. And so the idea that it could be expanding, that it could be getting bigger, would have been considered nonsense to the majority of people, to the majority of scientists anyway. And it wasn't until the 1920s that we were actually able to measure redshifts of galaxies, and we found that indeed the galaxies are all sort of moving away from each other and from us, and that indicates that the entire universe is getting bigger every second of every day. That's kind of neat. But that's something that the Bible teaches. And it's really interesting because the only way you could know about the expansion of the universe by scientific means, you'd have to have modern instrumentation. You need a spectroscope to measure redshifts, and you need a telescope to be able to see these distant galaxies, right? And those technologies did not exist in the 700s BC when Isaiah was written. So it's almost as if the Hebrews had some kind of divine insight into this issue. They have connections. Some people have asked, does this prove a Big Bang? Because if the universe is expanding, then if you run the time backwards, doesn't that mean everything goes back to a point? Doesn't that mean it exploded into existence 13.8 billion years ago? The answer is no. Just because something's getting bigger, just because something's expanding, doesn't mean it exploded into existence billions of years ago. Some of you are getting bigger. That doesn't mean you exploded into existence billions of years ago, right? Yeah. We get that. The universe started with size, and God has stretched it out since then. There's no rational basis for assuming it started with no size. So anyway, and some people have said, well, at least isn't this at least evidence for the Big Bang? Because didn't the Big Bang predict that the universe should be expanding? No. The expansion was discovered in the late 1920s. The idea of the universe coming from a point was 1931. Lemaitre, the inventor of the Big Bang, already knew about the expansion of the universe and was coming up with a naturalistic way to explain it. Okay, so it was not a prediction, not of the Big Bang. It's a secular way of explaining the expansion that the Bible talks about and did predict long before it was discovered by scientific means. So pretty neat. Conservation of energy and mass. There's a principle in physics that the amount of stuff in an isolated system is constant. So stuff doesn't just come into existence and stuff doesn't just cease to exist. You can change one kind of energy to another, but the amount of energy is constant. And likewise with mass. And Einstein tells us that mass and energy really are the same thing. They're just measured in two different ways. And we would expect this, though, on the basis of Scripture, because God is done creating in terms of creating physical material, right? Until the consummation, anyway. So all things are made by Him, according to John 1:3. Jesus made everything. And on the seventh day, God ended His work of creation. So He's done creating the universe. And He's still working in the universe, but He's done in terms of the physical creation. And that means no new material can come into existence, because either it would mean that something can come into existence apart from God, which cannot be because all things were made by Him, or it would mean that God is still creating, which cannot be because God ended His work by the seventh day. Okay? And then furthermore, we would not expect material to cease to exist because God upholds all things by the word of His power, and by Him all things consist or hold together. So nothing's going to cease to exist either. God allows us to change the material in this universe and to use it, but He doesn't allow it to cease to exist, and He's not making new material. Now, does this preclude a miracle? No, God can do what He wants. And so if Jesus wants to increase the mass slightly of the fish and the bread, He can do that. It's not a problem. But in general, God He's done creating, and so we'd expect that, barring a supernatural action of God, the amount of stuff in an isolated system is constant, right? The only way you can change it is to bring new stuff in or to pull stuff out. And these two principles together are called the conservation of mass or the conservation of energy. And usually James Joule is credited with the discovery of conservation of energy, but he's 1800s. And so it was millennia earlier that these principles are elaborated in the Scriptures, which I think is pretty neat. And by the way, James Joule was motivated by the Bible anyway, because as many scientists were until modern times. But there's in one of his writings, he mentions that it makes sense that energy, he used a different name for it back then, that energy would be constant because God is done creating. And so it's kind of interesting. If you want to get good science, you better start with the Bible. Countless numbers of stars. The Bible describes Abraham's descendants as the stars of heaven and as the sandwiches upon the seashore, indicating a humanly uncountable number. God counts the number of stars and has a name for each one, but we can't. And the Bible says that in another passage. It says, which cannot be numbered for multitude. And so that indicates a humanly uncountable number. And that's a pretty good analogy, isn't it? Yeah, if you wanted to indicate an uncountable number, the stars of heaven, the sand of the seashore. Yeah. But it might have been hard to believe when it was written, because the number of stars you can see naked eye is somewhere between 3,000 and 10,000. That's pretty big, but it's countable. And so people might have, I don't know if they did, but they might have criticized God in the past for saying, sand on the seashore, yeah, that's uncountable. Number of stars, we think there's about 3,000 to 10,000. And then the telescope was invented in 1608. And in 1610, Galileo had made his own, and he pointed it up at the Milky Way, that cloudy band, and said, oh, that's hundreds of billions of stars. And you cannot count to 100 billion in your lifetime. Can't do it. Not that you want to. But yeah, isn't that interesting? So, do we get the point? Have we learned the lesson of history? In the past, whenever the experts of the day have disagreed with the Bible has always turned out to be right. Right? Those experts who said, well, no, we think the Earth's a flat disk and floats in water, and we think the universe is static, it can't be expanding, and so on and so forth. We think there's about 3,000 stars, and so on. Those people are what we call wrong. The Bible is right. What about today? Have we learned that lesson of history? Not everyone has. I hope you have. God's word is always right. You can have confidence in it. Properly exegeted, I understand that. We need to do our due diligence and make sure we're extracting the meaning that God has placed in the text. I understand that. But there are folks today who say, yeah, but I'll grant you the Bible got those things right, but there's some things it got wrong. And one of them is the age of the universe, right? Because we know the universe is billions of years old. But in fact, there are many lines of evidence that confirm the universe is thousands of years old. I want to share some of those with you. I do have to point out the Bible does teach a young universe. I'll cover that tomorrow if you're able to come back for the morning service here. But the Bible teaches that God created in 6 days. Yes, it's clear from context. Those are ordinary, approximately 24-hour days. They can't be 6 ages. We'll go through the text on that tomorrow. And human beings are made on the 6th day. And we add up the ages of the patriarchs from Adam through Abraham and so on, and other information given in Scripture. We know that the time scale between the creation of Adam and Christ's earthly ministry is about 4,000 years. And given that Christ's earthly ministry was about 2,000 years ago, that makes the age of the universe about 6,000 years. The Earth's actually first. The sun, moon, and stars are made on day 4, right? So Earth's 3 days older than anything else in the universe. Kind of interesting. But it's not millions or billions of years old. And there's evidence that confirms that. And you tend not to hear about this very much because it's a problem in the secular view. But Jupiter, for example, emits twice as much energy as it receives from the sun every second of every day since creation. It's getting 1 unit of energy from the sun, it gives away 2. Brings in 1, spends away 2. Kind of like our federal government, right? There you go. And it's been doing that for 6,000 years. And like our federal government, it can't do that forever. Yeah. Because eventually Jupiter runs out of energy. And in fact, the way to think about this, if you've microwaved a potato and you take it out, you can feel the heat coming off of it, right? Yeah, it's radiating that heat away. You come back 2 hours later. It's cold, right? It's radiated away all of its energy. Jupiter's like that, except it's a much bigger potato. And so it can do that for a few thousand years. And it still has internal energy, but it can't be billions of years old, or it would be an icicle by now. So it still has internal heat. It's not that Jupiter's warm, it's just warmer than it should be if it were billions of years old. Okay, it has internal heat. And likewise, Neptune. Neptune is 4 times the size of the Earth, and it's farther away from the sun than Jupiter. It gives off 2.6 to 2.7 times as much energy as it receives from the sun every second, every day, for the last 6,000 years. And it still has some internal energy, which means it can't be anywhere near billions of years old. This is a problem in the secular view, and I've read some papers where they've attempted to solve it. And they have to apply a different solution for every planet because there's no one solution that works for all of them. So anyway, it's interesting. Not all the planets do that, but a lot of them do. The magnetic field of the Earth. The Earth has that protective magnetic field. That's caused by electrical current in Earth's core. Maybe you've made a little electromagnet by taking a coil of wire and touching it to a battery. And that surrounds our planet like a shield, and it's what causes your compass to point north. It protects us from radiation that would be harmful from the sun and also from other stars, cosmic rays. And so it's a design feature. We're grateful that we have a magnetic field. But because it has electrical current, it decays over time. We would expect that. Magnetic fields naturally weaken over time because that electrical current encounters resistance. Batteries run down. And our magnetic field is like that. It's like a battery that's running down with time. And it's been doing that since creation. Now, we think the field flipped rapidly during the flood year due to the plate tectonics. There's some interesting models along those lines. John Baumgartner and so on. Russ Humphreys have worked on that. But in terms of the energy, it's just been dropping since creation. So you start with a lot of magnetic field energy, and it's been dropping. It's kind of an exponential decay, so it kind of flattens out. And so eventually your compass won't work, right? But okay. And you run the equation backwards, though. Assuming it is an exponential decay, which it seems to be, you find that the Earth's magnetic field, if you run it back 60,000 years into a hypothetical past, the magnetic field would have been stronger than that of a neutron star, which is enough to rip the atoms of your body apart. You don't want that. So it can't be anywhere close to 60,000 years old, let alone a million, let alone 4.5 billion. So you see, it's very consistent with the biblical time scale, but it's not remotely consistent with the idea of billions of years, the secular idea. And the interesting thing is it's not just Earth's magnetic field. Some of the other planets out there have magnetic fields. Jupiter's magnetic field is extremely powerful. It'd be bigger than the sun if you could see it. It's amazing. And since that magnetic field decays with time, eventually Jupiter should run out of magnetic energy, but it hasn't, because it's only a few thousand years old. And likewise, the planets Uranus and Neptune. So here's Uranus. And it's a blue planet about 4 times the diameter of the Earth. And it has a magnetic field. And this was shocking to the secularists who were expecting that, Uranus being 4.5 billion years old, that's the alleged age of the solar system, that magnetic field should have run down a long time ago, should have exhausted its energy. Interestingly, Russ Humphreys, who's a friend of mine, and he's a creation scientist like myself, he's a physicist, he's got a model for how God might have started the magnetic fields back at creation. And he's able to explain the magnetic field of all the planets that had been measured at that time. And at the time he came up with this, the magnetic field of Uranus and Neptune had not been measured yet. And so he made a prediction. Based on 6,000 years of decay, their current magnetic field should be here for Uranus and similar for Neptune. He predicted that in 1984. Voyager 2 flew past Uranus in 1986 and discovered the magnetic field that matches Dr. Humphrey's prediction. Isn't that interesting? The secularists were way off. And likewise, in 89, it flew past Neptune and again confirmed Dr. Humphrey's prediction. Isn't that interesting? You see how good science confirms creation? It always does. The little bright spot you see at the bottom there, that's Aurora Borealis. That's northern lights on Uranus. And those of you that know anything about the northern lights, they're caused by disturbances in the magnetic field. And this is much farther away from the sun than Earth is, so the fact that you still have aurora indicates it has a significant magnetic field. Now, the magnetic field is not aligned with the rotation axis, and that's interesting because my secular colleagues, now that they know that Uranus and Neptune have magnetic fields, they've had to try to explain them. How are they still there? And so if you've heard of a dynamo model, that's the idea that the magnetic fields somehow recharge themselves over billions of years. And the idea is it works like the alternator in your car, which takes mechanical energy and turns it into electrical energy. And yeah, that's possible, but that's a pretty sophisticated mechanism, isn't it? As far as we know, planets don't have anything like that. And the dynamo model, really, in order for it to work, it requires that the magnetic axis and the rotation axis be pretty well aligned. And on Earth, they're pretty close. But with Uranus, they're not even remotely close. You see the rotation axis and then the magnetic field axis? They're totally different. And likewise with Neptune. The magnetic field on Neptune doesn't even go through the middle. It's kind of like stuck in the side. So it's consistent with biblical creation and the predictions made by Dr. Russ Humphreys. That's good science right there. The recession of the moon. The moon is actually spiraling away from the Earth. Every year it moves away a little bit by about 1.5 inches every year. And we can measure that, believe it or not, because of those reflectors we left on the moon. We can time the round-trip speed of light and get the distance within a fraction of an inch. And it's been doing this as long as we have had instruments to measure it. We'd expect it because the moon induces tides on the Earth, right? That's what causes the tides. This is the pull of the moon, the sun to a lesser extent, mostly the moon. And those tidal bulges, because the Earth rotates faster than the moon orbits, the tidal bulges get ahead of the moon. They pull forward on it, and when you pull forward on something in orbit, it moves out. It's a little counterintuitive, but if you've ever played with a gyroscope, you push it that way and it goes that way. It's kind of weird. But so the moon is moving away due to tides that it induces on the Earth, interestingly. It steals a little bit of the Earth's rotational energy and moves out. And if you run the equation backwards, at creation, about 6,000 years ago, the moon would have been 751 feet closer to the Earth, which is not a big deal considering it's 240,000 miles away, right? It's not even a 1 mile difference at creation. But if you run it back billions of years, you get a problem. And you have to do the math right because as you run it back, the tidal bulges would be bigger because the moon's closer, right? And so it would be faster in the past. And so if you have to use calculus to do it right. But when you do that, you find that the Earth and moon would have been touching at 1.4 billion years in the hypothetical past. They'd be in the same place at the same time, and that's not good. Okay. And before that happened, they'd shred each other due to tidal forces anyway. Or at least the moon would be shredded. So there you go. So you say 1.4 billion, that's quite long. Yes, but it's less than the 4.5 billion years that's supposed to be the age of the Earth and the moon. You see, 1.4 is less than 4.5. I'm saying that for the Common Core folks out there, in case there are any of you. If there's a worse way to do math, I don't know it. Okay, so it's an upper limit. A lot of these age estimates are upper limits, you understand. We're not trying to get the true age of something. We're saying it can't be older than X, and X is less than the secular age. That's the problem. Comets, we mentioned this earlier, that comets are made out of ice and dirt, and they orbit the sun in elliptical paths that bring them close to the sun every orbit. And when they get close, they sometimes disintegrate. I used the SOHO spacecraft in my doctoral research, and it has an instrument that it looks at the sun, and one of the instruments on it blocks the sun and looks at stuff real close to the sun. So comets, when they get really close to the sun, they get bright, and they're hard to see from Earth when they're close to the sun because it's daytime. But SOHO is designed to detect that. I've seen comets that have gone behind the sun, and they're now gone. I've seen comets that do not exist anymore. They don't last hundreds of thousands of years, let alone millions, let alone billions. And again, my secular colleagues say, well, there's an Oort cloud that makes new ones. There's no evidence of that. So there seems to be evidence that comets are an indication of the youth of the solar system. Spiral galaxies. Spiral galaxies, not all galaxies are spiral, but a lot of them are. And those that are spiral rotate differentially, which means the inner portions rotate faster than the outer portions, indicated by the arrow length that you see there, in terms of the angular velocity. The stars on the inside make a loop faster than the stars on the outside. And so if you think about what that's going to do to the shape, if the insides are rotating quicker than the outsides, the shape's going to get tighter and tighter, isn't it? It would have to. So if you run it forward in time like 100 million years, the shape gets twisted beyond recognition. You would not see a spiral structure anymore. It would look like an old-fashioned phonograph record in terms of how tight the spiral is. It'd be indistinguishable from a uniform disk. But we don't see any galaxies like that. All the galaxies we look at appear to be young. And yet they're supposed to be 10 billion years old in the secular view. But they can't be older than 100 million years or they'd be twisted beyond recognition. They don't even look anywhere close to that. They've spun up a little bit since God made them. I think he made them already spiral, and then they've twisted up a little bit since creation. You might notice that the arms of that galaxy have a bluish tinge to them. That's true. That's because the arms of spiral galaxies tend to have a higher proportion of blue stars than the core, and blue stars are a problem in the secular view because they can't last billions of years. Blue stars have the most mass available, the most fuel. Stars are powered by themselves, their own mass. They fuse their own material, hydrogen into helium in the core. And blue stars are the most massive. They have the biggest gas tanks, but they get very poor gas mileage, right? They're like an SUV, so they can't go very far in time. And the brightest blue stars can't last more than like 1 million years, the very, very hottest ones. And that's not disputed. My secular colleagues would not dispute that. They know that blue stars can't last billions of years, but we have them all over the universe. So the secular view is, well, they must have formed recently, okay? And if you've heard of, maybe you'll see in a newspaper article or something, we think this is a star-forming region. Let me clue you in on what that means. It means there's lots of blue stars there. They don't see any stars forming. No one has seen any stars forming, okay, or in the process of formation. There's nothing like that. Gas tends to not want to just collapse in on itself. Gas tends to expand in space because the gas pressure is orders of magnitude larger than gravity in a typical nebula. And so I don't think stars do form. I think the ones that were created by God, and they're still around because the universe is thousands of years old. So there you go. But aside from the age of the universe, there's another issue where my secular colleagues have not yet quite caught up to the Bible, and that is concerning the uniqueness of the Earth. The Earth really is very special. The secular view is, no, Earth's just one planet amongst hundreds of billions where the chemistry happened to be right for life to evolve. But biblically, the Earth is unique. Remember, God spent 5 of the 6 creation days working the Earth? Took 1 day and made everything else? Well, science confirms what the Bible teaches. God formed the earth to be inhabited, the Bible says in Isaiah 45:18. And that's one of the things that's unique about Earth is it has all these magnificent properties that are required for life. So you have an abundance of liquid water on its surface that's required for life. And you have that protective magnetic field that protects us from cosmic rays, which can cause mutations and cancer and all kinds of negative things. So, we have a large moon that orbits the Earth that stirs up the Earth's oceans and keeps them from stagnating. All kinds of life features on this planet. Earth's 3 days older than anything else in the universe. It's made on day 1, everything else made on day 4. Earth is very special. And most importantly, this is the planet where God walked, where God became a man and paid for our sins. That's awesome. The other planets, I'm glad God created them, but they don't have the uniqueness of Earth. The moon, one of the astronauts who walked on the moon referred to it as a magnificent desolation. I think that's a wonderful description. It has a beauty to it, but it's a desolate beauty. There's no color whatsoever. There's no plants. There's no animals. There's no atmosphere to speak of. It's a desolate beauty. It's beautiful, but it's a desolate beauty. It's not designed for life. The temperature difference between day and night, hundreds of degrees. You couldn't survive that. You can't breathe. There's no air. The astronauts who went to the moon had to bring a little bit of Earth with them, right? They had to bring some air from the Earth and some water from the Earth and some food from the Earth to survive as long as they did. And they didn't want to stay because the moon is usually outside of Earth's magnetic field, so there's not much protection from cosmic rays. So short exposure is no problem, but if they ever set up a base on the moon, that's something they're going to have to think about. Not designed for life. Earth's neighbors. You got Venus on the left, Mars on the right. Venus is about the same size as the Earth. So you might think, oh, that'd be a fun planet to go to. No. Bad decision. The surface temperature of Venus is 900 degrees Fahrenheit because of that thick atmosphere that traps in heat. The atmosphere itself is like 100 times the pressure of Earth's. So if you didn't burn up immediately, you'd be crushed like a tin can. And those clouds, sulfuric acid. There's lots of ways to die on Venus. It's just a question of, it's just a question of which one's going to get you first. So, people say, why would God design a planet like that with a poisonous atmosphere and 900 degrees Fahrenheit? You're not supposed to go there. He didn't make it as a vacation spot, right? He made it to be beautiful, and it is. It's that beautiful star you see in the evening or in the morning. It's now in the morning sky, for those of you that are early risers. That beautiful star you see in the east, that's Venus. Very pretty. You got Mars out over to the right there, and Mars is about half the size of the Earth, and it's better in terms of it'll kill you slower. Okay. But it doesn't. The atmosphere is unbreathable. It's carbon dioxide. But you could bring a spacesuit with you, and you could survive a little while on Mars. But it doesn't have the Earth's protective magnetic field, so you're not insulated from cosmic rays. There's no liquid water on it, as far as we know. There's evidence that there was liquid water in the past. That's a different talk. But in any case, not designed for life. Not designed for life, and it's abysmally cold as well because it's further away from the sun, and there's not a lot of atmosphere to trap in heat. So it's kind of like Goldilocks and the Three Bears. You got the two on the left, too hot, one on the right, too cold, and Earth's just right. And that's because God put it at the right distance from the sun to receive the proper amount of heat and light. And of course, we'd expect that. Which then brings up the question of what about extraterrestrial life? And I'll grant the Bible doesn't directly say one way or the other. I think that's true. Nonetheless, the earth was formed to be inhabited, and God doesn't say that about anything else. And science so far confirms that. The earth is special in that it's designed for life, and it's the only place we've been able to find life, unless we transport it. Bacteria have survived trips to the moon and back, which is kind of interesting. But Earth's the only place we find life natively. And if you have intelligent life, you got some theological issues you got to think through, right? Because if there are civilizations out there, well, the Bible says God made from one man all nations. Oh, you can't have civilizations out there that are not descended from Adam, right? Well, what if you have individuals out there that are intelligent? You got some theological problems to think through, because the reason that we're eligible for salvation is because Christ is our kinsman redeemer. He's our blood relative. That's why his blood counts for us on the cross, you see. But Lieutenant Worf is out of luck because he's a Klingon, and he's not related to Jesus, you see. So no one to pay for his sins. People say, well, maybe Jesus went to the Klingon homeworld and died for them too. No, because the Bible says he was raised incorruptible. He died once for all. He's not going to die again. And he died for human beings, his elect, in fact. So there you go. So I think there's some issues you're going to have to think through. What if the Klingons never sinned? Well, then they're suffering the effects of the curse, because all creation groans under that bondage of corruption. And so that's a problem too. So I would not expect to find life out in space. That's my take on it anyway. And I think that's reasonable. But again, I'm not saying the Bible directly teaches that. But it is interesting, though, because the secularists are puzzled by the fact that we haven't found life out in space yet. Enrico Fermi, who was a brilliant physicist, part of the Manhattan Project and all-around scholar, at one point he blurted out, "Where are they?" He had been doing a little calculation in his head that, if life evolved on Earth, it probably evolved elsewhere. It's an old universe, billions of years old, probably evolved in several places long before it evolved on Earth, in which case those should have evolved into intelligent creatures and been spacefaring and have colonized the galaxy by now. But the galaxy is not colonized. So where are they? And I suggest they're not there. But it is interesting, all this hype about finding extraterrestrial life. Why is that? You ever thought about that? Why there's such a drive for that? Because it will be nice to know that we're not alone in the universe, and maybe, if we ever meet extraterrestrials, they'll have advanced technology that we can use to cure our various diseases and so on. Maybe they've even figured out the key to living forever. And if you think about that, that's a secular replacement for God, isn't it? We're not alone in the universe, there's God. And we're designed to be in fellowship with him, and when you reject that, that need comes out in other ways. And God is the one that can heal all our diseases. God is the one that can give us eternal life. So it's interesting when people reject the biblical God, how that need comes out in other ways. It really is. So I think that's why there's a lot of hype. And I've had a chance to talk with some secular scientists about that, and I think that's kind of their take on it. What about starlight? I want to spend some time on this because it's an interesting issue, and it's one where the secularists think they've got us. Because they say, the universe is so big that light, as fast as it is, should take billions of years to get from those galaxies to the Earth. And we do see the galaxies, right? So the light has got here, which means the universe has to be billions of years old. So the Bible's wrong. Of course, if you say that, you haven't learned the lesson of history, because people have been saying, for millennia that the Bible was wrong about the shape of the Earth and about the expansion of the universe, and the Bible's always been right. So let's not repeat that mistake. But the idea is, we know the speed of light. We can measure that in a laboratory. And it's fast. Speed of light's 186,282.397 miles per second. It's fast. It could go around the Earth 7 times in 1 second. It's fast. But galaxies are even more far away than light is fast, if that makes sense. Galaxies are so far away that even at that incredible speed, it would take billions of years for the light to get from there to here. And we see them, which means the light has gone from there to here. Okay? So this is sometimes called the distant starlight problem. Secularists think it's a way to refute the Bible, but it isn't, as we'll see. I do have to point out, though, that many of the solutions that people propose don't work. And I want to bring this up because a lot of times when I give you what I think the answer is, it's a little bit complicated, and people have thought, well, isn't there a much simpler answer? We've thought of those, and they don't work. Okay, so for example, some people have said, well, maybe the galaxies really aren't that far away. Well, no, they're far away. They're not all within 6,000 light years. Okay, so and there's good evidence for that. I'm not going to go into the details, but that's based on good science. It's not based on evolutionary conjecture or anything like that. Some people have said, well, maybe the speed of light was faster in the past. And that was a good question to ask, because a lot of times that's the answer. A lot of times when people, secularists will say, well, this canyon couldn't possibly have formed quickly because at this rate, yeah, but it hasn't always been at that rate. But we think there's good evidence the speed of light's always been what it is today. There's very compelling evidence for that, including the fact that the speed of light is unlike other speeds. It determines the relationship between magnetic fields and electric fields. It determines the relationship between energy and mass. And so if you fiddle with that too much, matter might not even be possible. So we think there's a constraint on the round-trip speed of light. Some people have said that maybe the light was created in transit. So when God created the stars, he also made beams of light connecting them to the Earth. And that's an interesting idea, but I think there's a problem with that. The light in transit requires God to create fictional images and movies of things that never happened. Some people think, well, this is mature creation. Well, I agree God made a universe that's mature in the sense that it was completely functional by the end of the 6th day. It was totally functional. I get that. But that doesn't necessarily mean that God is making beams of light. If he did, then we have some issues to think through, because here we have a picture of supernova 1987A. So that little star that the arrow is pointing to on the left frame, that's what it looked like before 1987. And then in January of 1987, that star blew its guts out. Very sad. But it was rather spectacular. So if you got to go, supernova, right? Briefly became as bright as the rest of the stars in the galaxy. So it's pretty spectacular. And that little star is 168,000 light years away. What's a light year? A light year is 1 light year, 6 trillion miles. Okay? But in secular thinking, in standard thinking, if it was 168,000 light years away, then that's how long it took the light to travel that distance. That's why we use that distance indicator. And so in the secular view, this thing actually exploded 168,000 years ago. And then the light finally reached the Earth in 1987, okay? Today it looks like that. You're seeing expanding star guts there, basically. Okay, that's the nebula you see on the right. Now, if you say, no, the reason we're able to see that, it's not because the light took 168,000 years to get here. It's that God made the beam already on its way, and therefore he made pictures of the star in the beam, about 6,000 light years in length, and then he started making pictures of the star exploding and so on. What that would mean is that that star never existed, and that explosion never actually happened. Now, the question is not, does God have the power to do that? Of course he has the power to do that. He's God, he can do what he wants. But God made our senses to be basically reliable, right? And so I would argue that God was not going to create fictional movies out in space of things that never happened. And you say, I don't know, I think God would do that. Careful, because how do you know I'm even here right now? How do you know God's not? You say, well, we see you. Yeah, but maybe God's making the light, right? 1 inch away from your eye. Well, we hear you too. Well, God's making the sound 1 inch away from your ear, right? You could be a brain in a jar, and God's just feeding you input. No, God created the real universe, okay? And so he's not going to create fictional images or fictional movies. So I think I hope that makes sense as to why I would reject that. Humphreys came up with an interesting model involving time dilation. And we know from Einstein that clocks can tick at different rates under different circumstances. And although I think Humphreys' model was a really clever idea, the math just doesn't work out in terms of actually getting the starlight here in 6,000 years. So that little model he came up with in the 90s, by the way, he doesn't hold to it anymore either. So he's moved on to another model and then one after that. Here's what I think the answer is. And it's a little bit more complicated than what you'd hope, but it's not that bad. The solution may involve what we call the one-way speed of light. The speed of light, which is abbreviated by the lowercase c, is 186,282 miles per second. Very fast. But that is a round-trip average speed. What do I mean by that? Well, basically, the way you would measure the speed of light, in principle, is I'm going to stand over on one side with the flashlight. I'm over there where the flashlight is, and I've got a clock with me, a stopwatch, okay? And then we'll build a long hallway. We'll build it 186,000 miles long. We'll pretend we have government funding. We can waste it that way, okay? And then on the other end, we'll put a mirror. And when my clock strikes noon, I will turn on that flashlight for just an instant, and the light pulse will travel down, hit the mirror, and then when I see the reflection, I'll look at the clock and see how much time has elapsed. And it turns out if we did that, I would see the reflection 2 seconds later. Kind of amazing to think about. We think of a reflection in the mirror as instantaneous. It's not quite. It's not quite. It's close. But if we had a hallway that long, it would take, that's a fraction of the distance to the moon. And we would see the reflection 2 seconds after I hit the button. And so what you do is you say, okay, light traveled a distance of 186,000 miles twice, so 2 times that, divided by 2 seconds. Distance divided by time is speed. And so that's where you get the 186,000 miles per second. That's where it comes from. Now, most people assume that the light took 1 second to go out and 1 second to come back. And you could be forgiven for thinking that because I've depicted it that way. But I don't actually know that, do I? Because I'm only where the flashlight is. I can only see light that enters my eye. And so how do I know where the light is? I don't know where the light is until it reaches my eye. I know where it started and I know where it ends up, but I don't know where it is at any given time. In other words, hypothetically, it could be the case that the light took no time at all to go out to the mirror and all 2 seconds to come back, right? 1 + 1 = 2, but so does 0 + 2. Could be that, right? I would get exactly the same answer. I would say, well, it traveled a total distance of 186,000 times 2, divided by 2. I get the same average speed. Even though on one leg of the trip it's traveling infinitely fast, on the other leg it's traveling at half c. Or it could be the reverse. It could be that the light takes all the 2 seconds to go out and hit the mirror and then it zips back. Okay? Interesting. I'd get the same answer. In all cases, I started at the same time and I see the reflection at the same time. And so I can measure the average speed, but I can't measure the speed in one direction. It could be different. And people say, why would it be different? I don't know, but I don't know why it would be the same either. You can't just assume something in science, because wouldn't that be nice, right? In fact, I'm kind of rooting for the bottom one, because if that's the case, if light, when it's moving toward an observer for whatever reason, is infinitely fast, then there is no starlight problem, right? Because that means we're seeing the universe in real time, because the light that we're seeing is moving toward us. Now, if we were to send a signal back to that galaxy, then it would take a long time. But we don't have to send a signal back to see the galaxies. And so if the bottom case is the answer, then there's no starlight problem. So that's kind of what I'm rooting for. But again, wishful thinking, it does not make for science. We want to test what is the speed of light in just one direction, and is it the same as it is in the other direction, or is it different for whatever reason? I'm not suggesting there's anything special about the mirror. I could have my buddy over there, and he has a flashlight. When he sees the initial beam, he sends back the return. Okay, it could be both emission. It has nothing to do with reflection. I'm just saying perhaps light is such that when it moves toward you, it moves at a different speed than when it moves away. There's lots of weird things in this universe. Maybe light's like that. So how would we measure the speed of light in one direction only? Well, I'm going to have to use 2 clocks now. No mirror, because I just want to measure it on a one-way trip. So I'm going to stand over, and when my clock strikes noon, I'll send out the light pulse, and it'll go over and hit the other clock, and the other clock will record when maybe it's like a stopwatch, and as soon as the light hits it, it stops. And so it records the time. Make sense? Now, I tried this in my office. I don't have the long hallway, but I can convert. And I have the distance between my watch and the clock on my phone. And so as soon as my watch struck noon, I turned on the flashlight, and as soon as the phone was illuminated, I just read the time on the phone, right? Because that records the time that it arrived. I actually did that, and as soon as my watch struck noon, the light, it looked like it was instantaneous, but the clock read 12:05, and so I said, it must have taken 5 minutes for No? You're not buying that? That really happened. But wouldn't it be an error in reasoning to say that it really took 5 minutes? Because obviously what really happened is the clock on my phone is 5 minutes fast. It's 5 minutes ahead of the one on my watch. And so that's the point, is that this method would only work if the 2 clocks are synchronized, if they read the same time at the same time. We know what that means from the old spy movies, right? Let's all synchronize our watches, right? Read the same time at the same time. Okay, you think no problem, we'll make sure the clocks are synchronized. That turns out to be a huge problem, because it's not good enough for them to be approximately synchronized. If the clock on that end is 1 second fast or 1 second slow, it makes the difference between the speed of light being 1/2 c or infinity. It's a huge difference. So they can't just be close. They have to read exactly the same time at the same time. You say, no problem, we'll make sure they're synchronized. Well, how are you going to do that? Normally, the way we synchronize clocks is by radio transmission. There's a radio station in Fort Collins that's connected to the atomic clock in Boulder, Colorado, and it sends out a signal constantly. And one of the clocks I have in my apartment receives that signal and sets itself to the atomic clock. We nerds like that kind of stuff. It's just neat. So there you go. And so it's synchronized with the atomic clock. But is it exactly synchronized with the atomic clock? Because that radio pulse, right? So the radio pulse says, okay, it's noon, and then the other clock receives it and says, okay, I'm setting myself to noon. But the radio actually takes a little bit of time, potentially, to get from the radio transmitter to the clock, right? Now, if I knew how much time, like if I knew it took 1 second to get there, I could say, okay, instead of setting my clock to noon, I'll set it to 12:00:01, right? I could compensate for that if I knew how fast radio travels. Do you know how fast radio travels? Speed of light. Oh. Well, that's the very thing I'm trying to measure, right? That's the very thing I don't know if it's the same speed in both directions. Some people have thought that if you put the radio transmitter in between the two of them, that'll work. Because then they'll both be behind, but they'll be behind by the same amount, so they'll be synchronized. Yes, if the speed of light, and therefore the speed of radio, is the same in both directions. If it's not, then one clock gets set to noon first, and the other one gets set to noon later. And they're not synchronized, you see. So in other words, you can't synchronize 2 clocks by radio transmission unless you already knew the one-way speed of light, the very thing I'm trying to measure. So that's not going to work. As a last resort, people have said, well, maybe we'll bring the 2 clocks together and synchronize them, and then we'll move one or both to opposite ends of the hallway. Okay? Now, when their 2 clocks are right there, you can tell they're synchronized because they're reading the same time at the same time. That's easy. Okay? You say, okay, and we'll move them then, and the assumption is that they're still synchronized. But one of the things that Einstein discovered is that motion affects the passage of time. Now, it's a small effect, but you add it up over that distance, it could be more than a second, which makes the difference between the speed of light being half c or infinity. So it adds up. It's a huge effect on the kind of distances we're talking about. Isn't that interesting? So the very act of moving the clock has caused it potentially to become desynchronized with the other one. Isn't that fascinating? Now, perhaps not all is lost. There is a formula that tells you how much time is gained or lost by the moving clock. Okay? So there's a formula, and so I can know how much time is added, and I can fix it. But in that formula is the speed of light. You see, you're getting it. That's good. That's good. So here's the conundrum. Apparently, it's impossible to exactly synchronize two clocks separated by distance without already knowing the one-way speed of light. And it's impossible to measure the one-way speed of light unless you have two clocks exactly synchronized and separated by distance. Each one requires you to know the other one first. It's catch-22, which means it's impossible to ever know the one-way speed of light. Can't be done. You see, and you can see why. And please don't come up and say, I think I've thought of a way. You haven't. Over the past century, physicists, because some physicists have said, that's crazy, there has to be a way to do it. And I've read, I don't know how many technical papers where people have tried to come up with a method to measure the one-way speed of light without first assuming it. And then in the next issue of the same paper, somebody refutes it and says, no, you made a false assumption here, and that nullifies your result. It's really interesting. But that was a huge topic in the 20th century after Einstein, because Einstein was aware of this. And it's kind of interesting. You cannot measure the one-way speed of light objectively without first assuming it, because you need to assume the one-way speed of light in order to synchronize clocks. It's quite fascinating. So when you have a situation like that, where each thing requires you to know the other first, that suggests that what you're trying to measure is not actually a property of nature, but a convention. A convention is something we all agree upon, and it works. Like driving on the right side of the road is a convention. We all agree on that, and it works. And you go to Australia, and the left side of the road, and that works. The one-way speed of light is like that. You can choose what you want the speed of light to be within certain constraints, anywhere from 1/2 c to infinity. And then the return speed is determined by the fact that the round-trip speed has to average to c. But in any one direction, you can pick what you want the one-way speed of light to be, use that to synchronize your clocks, and then when you measure the speed of light, it'll be exactly what you chose, if you're consistent. Isn't that interesting? Just apologetics aside, I think that's fascinating that the Lord has designed the universe in such a counterintuitive way. So the one-way speed of light is not a property of nature. It's something we choose. Therefore, I'm free to choose it to be infinite when it's toward me, as long as it's half c when it's away from me, and c when it's at a right angle. That'll work. Okay? So you might think, well, we could synchronize two clocks by having a lightning bolt in between the two of them, and when they receive the pulse, they synchronize themselves to noon. They're synchronized, right? If the speed of light's the same in both directions. So that light requires the same time to traverse the path A to M as for the path B to M is in reality neither a supposition nor a hypothesis about the physical nature of light, but a stipulation which I can make of my own free will in order to arrive at a definition of simultaneity. It's a quote by Albert Einstein. Einstein was well aware of this, and he wrote about it. So this is not something that some crazy creationist came up with. This is Einstein was not a creationist, unfortunately, but he was pretty brilliant, and he recognized that you cannot measure the one-way speed of light, so you stipulate it. And normally what physicists do is they set it to be the same in all directions because it makes the math easier. And it does, because you're imposing a symmetry on the universe. It makes the math easier. But you don't have to do it that way. One way you can do it is you can make the speed of light infinite when it's directly toward an observer, toward me, or toward you, and half c when it's moving directly away. And that will average to c when you do the time average. Okay? So that's how that works. And I'm going to call that the anisotropic synchrony convention. Anisotropic, different directions. So the Einstein version would be an isotropic synchrony convention. And that's legitimate too. Both are legitimate. The temptation is to say one of these is correct and the other one's wrong. Nope. Doesn't work that way, unfortunately. So using the ASK convention, light takes no time at all to get from those galaxies to here. And so the distant starlight problem is solved if the Bible uses it, if the Bible uses that anisotropic synchrony convention. And I think it does for a number of reasons. First of all, everyone did until at least the 1600s. Before then, when something happened in space, people said, okay, it's happening now. That defines when it's happening is when you see it. That's a very natural way of thinking. Really, you see a deer on the other side of the hill grazing, you say, I wonder how many millions of years ago that deer was really there. No, things happen when you see them. And that was the convention throughout history. It's the visual synchrony convention, or ASK in the way I'm naming it. But I think there's another basis for that. It's in the scriptures themselves. Then God said, let there be lights in the expanse of the heavens to separate the day from the night. Let them be for signs and for seasons and days and years. We find out that's the sun, the moon, the stars also, right? And let them be for lights in the expanse of the heavens to give light on the earth. And it was so. What was so? He made the stars and they gave light on the earth. As far as I can tell, biblically, stars immediately fulfilled their God-ordained role to give light upon the earth, which means the Bible was probably using an anisotropic synchrony convention, as all ancient cultures did until the 1600s. And we still use it today. We just consider it to be phenomenological, but that actually the physics works perfectly well in either convention. So I think we have a good answer to distant starlight. It's a little more complicated than people would like, but take it up with God. It's his universe. I mean, I wouldn't have come up with quantum mechanics, but hey. So again, we have some resources that I encourage you to get. Astronomy Reveals Creation is this presentation, and so you can pick that up on DVD if you want. The book that goes along with this would be Taking Back Astronomy. That covers all the issues except the distant starlight issue. That's not really in that. Worlds of Creation takes you on a tour of the solar system, showing you all these amazing images that we've had from the different spacecraft we've sent out there. So that's a lot of fun. Stargazer's Guide to the Night Sky, if you want to just better enjoy the night sky and or learn the constellations, or when's the next meteor shower, when's the next solar eclipse, the book will tell you, and how to view these things as well. If you want to get a telescope, what kind you might want to get, what to look for, what not to look for, and so on. So Stargazer's Guide to the Night Sky. Created Cosmos, that's the planetarium show I wrote for the Creation Museum. It takes you out to the edge of what we know as the universe and brings you all the way back into Earth. It's a pretty neat little program. The Physics of Einstein, if you'd like to learn more about the one-way speed of light, and it's just well as the other interesting physics that Einstein discovered, everything from time travel to black holes. Truth is stranger than fiction. The universe that God created is amazing, and the way it works is it's beautiful. There's a beauty to it. Not everybody can appreciate that, but I think most people can. This is written at a high school level, really. So you see, do I need to know math? You don't need to know any math.